So hi, this is Raji, and this presentation is based on page replacement algorithms and introduction to page replacement algorithms. The overview gives this presentation contains the details like why page replacement is needed and the basic techniques of page replacement and page replacement algorithms with examples. So first of all, why this page replacement is needed? That is because when a page fault occurs, like what is a page fault? We know that a page fault is a type of interrupt raised by the hardware when a running program accesses a memory page that is mapped into the virtual address space but not loaded in the physical address. When that occurs, the operating system has to remove one page from that is the memory is filled with pages, so the operating system has to replace one page from the memory to make space for the new frame. So this is done by swapping the required pages from backup storage to main memory and vice versa. So to decide which page is to be swapped, for that we are using page replacement algorithms. So the basic technique behind the page replacement algorithm or page replacement is like this. We have a page table and the physical memory and the secondary storage. And here first we are finding the location of the desired page in the disk. Then find a free frame if there is one. If there is a free frame, use it, or if there is no free frame, use a page replacement algorithm to select a victim frame, write the victim frame to the disk and change the page tables and frame tables accordingly, and then swap the new pages into that space. That is the basic page replacement technique. So the algorithms that are being used are the FIFO, optimal page replacement, and least recently used. These are the main important three algorithms that is used for page replacement. So each operating system, depending on the operating system, uses different algorithms to and the algorithms are selected with lowest page fault rate, and these algorithms are evaluated by running a particular algorithm on a string of memory references and compute the page faults. And for finalizing a page replacement algorithm, the page fault rate should be minimum. So let us move on to the algorithms. First let us see what is FIFO, that is first in first out. This is a very oldest page in the physical memory algorithms, and it is very simple to implement. Here in this algorithm, what we are doing is we are selecting an oldest page in the physical memory and it is replaced. That is we are replacing the first page that is added into the or the oldest page in the memory. So let us see an example. So this is an example page references, that is 1, 1, 3, 0, 3, 5, 6, and here we have 3 page slots. In these 3 page slots, first both the 3 page frames are free, so we are adding 1, so 1 page fault, and 3, again we have 2 free slots, 1 page slot, and also 0, we have 1 free page slot, so we are adding 0 here, 1 page fault. Again comes 3 is already present there in the memory, so no page fault. Again 5, when 5 comes, see here all these 3 pages are filled, so we have to replace any page for making space for the new page 5. For that we are selecting the oldest page that is residing in the memory. Here that is 1. By 1 is here the reference string 1 is added at the first time. So we are replacing it with 5. Then 530. Again we have another string that is 6. So 6 is not there in the memory. So we have to replace 1. For that, here 5 is recently came and the 30 are the strings to be available. Comparing those two, 3 is the oldest one. So we are replacing 3 with 6. So, and 1 page fault is there. So for this in total we have 5 page faults. This is FIFO. So there is we basically see that when we increase here the page size or frame size available is 3. So basically it states that when we increase the number of page frames, the number of page faults will decrease. It is usually like that. But in FIFO, here consider this example. Here for this string, the available number of page frames are 3, and here we are getting 9 page faults, and now we are increasing the number of page frames from 3 to 4. So here see here we are getting 10 page faults. For 3 frames we got only 9 page faults. When we increase, the page faults also got increased. That is called Belady's anomaly. So Belady's anomaly states that for some reference string it is possible to have more page faults when increasing the number of page frames. So that is Belady's anomaly, and that is all about first in first out. It is easy to implement, and it is implementing by queue and replaces pages accordingly, and it is very easy to implement. The main disadvantage of this FIFO is like pages which is being accessed quite often may also get replaced, and it ignores the locality of reference. These are the drawbacks of FIFO. For that, and again another type of algorithm is being developed, that is called least recently used. In this algorithm, the page that has not been used for longest period of time is selected for replacement. In FIFO, we used the oldest page, but in least recently used, as the name suggests, the page that has not been used for the longest time period is being selected for replacement. So let us see an example. Here this is the reference string 021640103121 is the reference string, and the number of page frames is available is 4. So here we have 0 placed in 1 page fault, 2 we have free space, up to 6 we have free space, so we are placed all those things, and we got 4 page faults. And here comes the 4 no page space, and 4 is not present here also, so we have to replace 1 page. That is what is LRU says that least recently used. Here 6 is here, 1 2, so 0 is the least recently used, so we are replacing 0 with 4. So now it is 4216. Again comes the 0 comes, we are replacing it with 2. Now 1, that is 0 is used right now, and 1 is there, so 0 page for 0 is also there now. Again 3, here 3 is not present. With which page we have to replace it with 3? Let us see. Here we have 0 is there, that is the most recently used, and 1, again 0, and 4. So 0 1 0 4. So the most 3 is there. So which one is the least recently used? 6. So we are replacing it with 3. Again 1 is there, so no page falls. Again 2. 2 with which page we have to replace? That is here, see, 1 3 0 1 0 4. So the most least recently used page is 4. So replacing it with 2. And again one is no. So total of 8 page falls. That is called least recently used. Now, this approach relies on assumption that page which has not been used for the longest time is the least likely page to be used in future. It has reasonably good performance also. And next comes optimal page replacement. In this algorithm, pages are replaced which are not used for the longest duration of time in future. That is, the future knowledge of reference string is virtual. That is, what string is coming, that knowledge is required for this optimal page replacement. Let us see an example. So this is the reference string, that is 701203042303, and here the page frame size is 4. So up to 2 we are able to store, that is free space. So we will get 4 page falls automatically. Again 0 0 is there. Now comes the 3. 3 is not there. So with which page we have to replace with a 3? We are replacing the page that is not being used in the nearly in the future. So 0 we will be using, no 4, and 2 we will be using, then 3, then 6. So 7 or 2 7 is not, or 1 is not being used. So we are replacing 7 with 3. Now we get 3 0 1 2. So 0 0 4. Then now comes the 4. 4, here we have 3 0 1 2. 2 we have to use here. 3 we have to use here. 1 here. Though 2 is there, present is there. 3, all these are present here. So in total 6 page falls. This is optimal page replacement, but this approach usually results in fewer page falls. But however, this approach is not feasible because the future the reference string, the complete knowledge of the reference string may not be possible. So this algorithm is not just, it is a theory, it is not implemented. So that is all about replacement algorithms. Thank you.